Hi, I'm Paul. We're doing Leetcode Must Know interview questions. Today's challenge is word break. Medium rating given a string S and a dictionary of strings. Word dict. Return true if S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay. Segmentation. Well, yeah, that's one way to think of it. So, example, the string is Leetcode. The words in the word dictionary are leet and code. Well, what we really want to see is, can we use those leet and code can we put those together in some order to make the string? And in fact, we can. Or the other way to think of it is, well, we could split Leetcode into these two words, leet and code. Apple, pen, apple works with this word dictionary. Words can be used more than once. Surprisingly, this just doesn't work. It seems to have a lot of promise. We have cats, but then that takes out the D, and then all we have left is OG. That isn't going to work. We could do cat, sand, and then we're in the same situation where we can't use dog because we already used the D, so it can't be segmented. All right, string length is between 1 and 300. That's good because there's not, as far as I know, a super efficient way of doing this. The word dictionary can have up to 1,000 words. Each word can be up to 20 characters in length, only lowercase English letters, and everything in the word dictionary is unique. So let's try an implementation. All right, so I'm going to just kind of talk through the implementation as we do it, rather than try to sketch it out. It's hard to sketch it out because, well, I guess it's mostly hard to sketch it out because of the indices in the nested loop. I think it's actually easier to understand if we don't go through and try to keep track of the values of the nested loop indices. So first of all, let's do this. We have a list here for the word dictionary. It's really going to be easier to do a lookup of these words if we put it into a set. So let's go ahead and do that. Where am I at here? Let's tab that in. Set. It's going to be a set of strings. And we can call it word set. That'll be a new hash set. And we'll pass in word dictionary to create that. All right, and so we don't have to keep referring to s.length. We'll put it into a variable. Okay. We need an array. It's a Boolean array, and it's going to keep track of possible word breaks. So Let's do it like this. Boolean, this will be the dynamic programming array. Boolean DP equals new Boolean str length plus 1. We need a plus 1 because we need to be able to handle index for, well, we need to handle 0 plus an index for every letter of the string. And this array, DP at some index is true if the first, well, let's say DP at some index I is going to be true if the first I characters of the string can be segmented into dictionary words. Okay. And we're going to start with this. dp0 equals true. Because I don't think that's not something that's going to happen, because the constraints say that the length of the string will be at least 1, but we still need that to make the algorithm work. All right, for int I equals 1. Why is it 1? You'll see in a minute. I less than or equal to string length I plus plus, and for int j equals 0, j is less than I, j plus plus. I is actually the well, if you think of j and I as a pair of indices indicating the start and end of a string, actually I is indicating the end of the string. So I is going to check every substring starting with length 1 and going to string length. And J is going to try all the different breakpoints in the substring. So let's do this. If dp at j if the string up to j, if dpj equals true, that means that the string up until index j can be broken into valid words. And we also want to know if word set contains the substring of S from J to I. If it does, then dp at I equals true. Because if dp at j equals true, that means we can get to index j and successfully break the string up into dictionary words. Now, if the word set, the word dictionary, if it contains the substring from J to I is always greater than J, the way we've set it up here. I is going to look at all the substrings from 1 to the end of the string. J is always going to start at 0, and it's always going to be less than I. So if we can split the string up to index J, and the substring from index J to index I is in the word set, then that means we can split the string up to index I. So we'll set dp I to true. And we'll break out of the loop since we found a valid breakpoint. Okay. We have 2 for loops here. I actually want to get to the end of the second for loop. After the second for loop, so we've got after, oh, no. This is in the wrong place, sorry. Okay. So we found a valid breakpoint. After this for loop, we're going to return dp at string length. And that is going to tell us whether we can break the whole string up into dictionary words. So this is a bottom-up dynamic processing. I'm sorry, dynamic programming problem. We tabulate the breakpoints. Anytime we find a breakpoint, we set it to true in the DP array, and if we can get all the way to the end and set the last index to true, then we can split the whole thing up, and that should return true. All right, let's try running it. All right, good. Submit. Okay. See, that's a little disappointing. I've seen that a couple times now where, yeah, okay, so here's our time right here. This is the most common runtime, but there are a number of faster runtimes. All right. You know, I'm still going to put it in the scorebook as a win, but that is, I mean, what is this? This is like a, I don't know, an n cubed algorithm. It's not a super efficient algorithm. Oh, it's only n squared. Okay. N squared is good for this. I mean, you can't really do better than that. But I don't know. Maybe there's some kind of constant factor that I'm overlooking here. Anyway, that is that is the solution for word break. Please feel free to like, subscribe, comment, and see you next time.